In previous lecture, we have seen how to calculate moles when grams are given or your molar volume is given or molarity and volume are given depending on gas, solid or liquid. Now what we are going to see right now is the next extrapolation of what to use those moles for, and the number one pattern that you need to know is finding limiting reagent. Limiting reagent problem தானாவே வரும், அது மட்டுமாவே இல்லனா இது ஒரு part of problem வரும். Okay, if it is a part of a problem, the numbers will be very easy in NEET. ஏனா அந்த நம்பரை வச்சு you have to calculate something else ன்ற மாதிரி. But if the problem itself is calculating which is the limiting reagent, then it might be a little bit more numerical. Okay, let's look into it. Now what does the limiting reagent mean? Now when you have a reaction, the reagent that gets used up first, too simply, let's take an example that we all know. H2 and N2 gives you 2NH3. Okay, Haber's process, we have already known this, and there is 3 hydrogens. Now you take a certain amount of nitrogen, you take a certain amount of hydrogen. The one that gets used up first completely is called a limiting reagent, meaning இது ஓரளவுக்கு எடுக்கிறீங்க, இது ஒரு அமௌண்ட் எடுக்கிறீங்க, எது முதல்ல யூஸ் அப் ஆகுது கம்ப்ளீட்டா, that is called a limiting reagent. And the one that is not used up completely, பாக்கி இருக்கிறது பேர் excess reagent. The name limiting reagent comes because it limits the amount of product or ammonia in this case that you can form. For example, nitrogen வந்து ரொம்ப கம்மியா எடுக்கிறோம் அப்படினா nitrogen முதல்ல யூஸ் ஆயிடும், மிச்சம் excess hydrogen இருக்கும். So nitrogen வந்து limiting reagent னு சொல்லலாம், hydrogen வந்து excess reagent னு சொல்லலாம். How much of ammonia is formed என்ற question கேட்கலாம். Or எது limiting reagent னு கேட்டதுக்கு அப்புறம் which will get used up first அப்படினு கேட்டா அதுவே எது limiting reagent னு கேக்குற மாதிரி தான். Or what I can ask you is which is the excess reagent னு கேட்கலாம். In our case, let's say it's hydrogen. It's simple. They can ask you how much excess reagent is left over, meaning எல்லா நைட்ரஜனும் யூஸ் ஆயிடுச்சுன்னா it will use up some amount of hydrogen. How much of hydrogen is left over? You need to calculate. The best example we can do is try to come to something that is common in life. Okay, let's take for example making lemon juice. Okay, this is very simple. So ideally what all we need for lemon juices, we need lemons, sugar, water and salt. Now for sake of simplicity, I am going to simplify this saying one lemon juice should have, let's say for example, one lemon juice should have half a lemon, okay, and let's say this 10 grams of sugar. Water is in excess, so we don't have to worry, we always have a lot of water at home, and we need 1 gram of salt. Okay. Now if I mix these, I get 1 cup of lemon juice for a guest maybe. Now how much lemon juice or how many cups of lemon juice can you make if a given amount of lemon, sugar and salt are there? Example, if somebody tells you the problem given is we have about 10 lemons, sugar we have 250 grams, water is in excess, I don't have to worry, excess ah irukradhanaala adu done out aga poradilla, salt I have 50 grams. This is what I have. Now how much lemon juice cup I can make, we are going to calculate it. Now what we need to do is, what is the maximum we can do with the given amount of each individual particles. Now lemon, so I have 10 lemons, what is the maximum I can do? 1 cup lemon juice ku we need half a lemon, so appo 10 lemons irukna we can make 20 cups of lemon juice. Alright, now when you look at it, 1 cup lemon juice ku 10 grams use panna porom, ana 250 grams irukku, so how many cups can we make? 25 cups is the maximum I can make. When I look at salt, I need only 1 gram, I have 50 grams, so I can make 50 cups of lemon juice. Now the question is, what is the maximum lemon juice you can make? Meaning they are not asking you which is the biggest number here. What is the maximum you can make அப்படினா இருக்கிறதுல lowest number நீங்க பார்க்கணும். ஏனா இதுல lowest வந்து 20 cups. நான் 20 cups lemon juice பண்ணதுக்கு அப்புறம் இன்னும் 5 cup பண்றதுக்கு எனக்கு பாக்கி இருக்கு sugar, but lemon இருக்காது. Similarly, after I make 20 cups, I have lot more salt left over, but I cannot use it because lemon runs out. Because lemon runs out, this is called the limiting reagent, these two are the excess reagent. So what is the maximum we can make? Okay, so what is possible? I can make 20 cups possible. How much is possible? 20 cups. 20 cups. So how much is used up? 20 cups will use up. Each cup needs half. 20 cups will use up 10 of them. Sorry, 10 lemons. Okay, left over 0. Going to the same here. Now how much is used up? Now 20 cups na sayya pora. Each cup needs 10 grams. 20 cup needs 200 grams. Again, ஒரு கப் லெமன் ஜூஸ்க்கு 10 கிராம்ஸ் யூஸ் ஆகுது. என்னால் மேக்ஸிமம் என்னால் பண்ண முடிஞ்சது 20 கப்ஸ் தான். ஒரு கப்புக்கு 10 கிராம்ஸ் அப்படின்னா 20 கப்ஸுக்கு 200 grams யூஸ் ஆகிடும். லெஃப்ட் ஓவர் என்ன? we started with 250 grams, left over is 50 grams. Similarly, going to our salt, 1 cup needs only 1 gram. அப்போ 20 கப்ஸ்க்கு எனக்கு தேவை 20 grams. அப்போ left over என்ன? 50 grams, 20 grams யூஸ் பண்ணிட்டேன், 30 grams left over. So this is my limiting reagent, this is my excess reagent, this is my excess reagent. Now we can extrapolate this to chemistry. Pattern எப்படிலாம் வரும் அப்படின்னா, what is the maximum amount of product you can form? In our case, இந்த எக்ஸாம்பிளுக்கு ப்ராடக்ட் வந்து லெமன் ஜூஸ். Okay, so lime juice எவ்வளோ பண்ணலாம் அப்படின்னா, we can do 20 cups of lime juice. That's one type of thing. Which is the limiting reagent ne கேட்கலாம். So we figured it out. Which are the excess reagent? Multiple choice option: lemons, sugar, lemon and sugar, salt and sugar, like this. So in our case, the excess reagents are salt and sugar. They can ask you how much of excess reagent is left over nu solittu multiple choice la kodukkalam. You know how much is left over. How much sugar is left over? 50 grams sugar is left over. How much salt is left over? 30 grams salt is left over. Now the higher order problem eppadi irukuna, what is the percentage of sugar used? Percentage of sugar used என்ன இருக்கும்? Percentage used 100% is used up, hence we call it a limiting reagent. How much percentage is used? What is it used? 200 grams. What is the total? 250 grams. Okay. Now depending on options, you don't have to calculate this. Okay. You don't have to calculate exactly. 80% வரும். But you don't have to, because multiple choice they might give you that, or otherwise you have to condense it. Here what is the percentage used? I used up 20 grams out of 50 grams. It's much easier. Now 20 grams out of 50 grams அப்படினா 50 grams க்கு 20 gram யூஸ் ஆகுது. அப்ப 100 grams க்கு எவ்வளவு gram யூஸ் ஆயிருக்கும்? 40 grams, meaning 40%. So this is 40%, 80%. Left over 0%, 20%, 60%. This is how limiting reagent problems can be solved. Now we will actually move on to using it in a real life example, let's say like a Haber's process or something, all right? We just saw how to basically look into calculating a limiting reagent, but we'll look into the chemistry problem side. I have picked up a problem from NEET, although it is called AAPMT 1998, and in the pattern la mostly varum. So this was the question given. They even gave you the balanced equation. They have told you when 1 mole of ammonia and 1 mole of oxygen is taken, which of the following is true? Now let's ignore the options because we are studying this concept right now. Let's look into what all we can do. Okay. Many things we can do. Limiting reagent la neenga paakano appadina multiple ways of doing to find which is the limiting reagent. Students who have already gone some training, who are re-repeating, might actually look into it and say the answer right away. But for those of you who just starting limiting reagent at this level, the best way to find out a limiting reagent is divide all of them by one of the coefficient. Okay, நீங்க 4 ஆல டிவைட் பண்ணலாம் இல்ல 5 ஆல டிவைட் பண்ணலாம். Now for example, I divide by 4. What I get is I get 1, 5 by 4, 1, 6 by 4. Right? Now if I divide by 5, what I get? 4 by 5, 1, 4 by 5, let me write it here, 6 by 5. Now this is to understand I am doing this pattern. Now what this tells you is basically எனக்கு 4 moles ammonia எடுத்தா 5 moles oxygen வேணும் to give you 4 moles NO and 6 moles H2O. Or I can say 4 moles க்கு 5 moles தேவைன்றதுக்கு பதிலா 1 mole க்கு 5/4 moles. All you have to know is this is greater than 1. This is less than 1. Okay? 1 mole க்கு I need more than 1 mole, right? Whereas here 1 mole க்கு I need less than 1 mole. So this is sometimes easy for some students to actually look into it, right? So now look into it. எனக்கு 1 mole க்கு 1 mole அதிகமா வேணும் oxygen, or 1 mole oxygen க்கு எவ்வளவு ammonia வேணும்? Less than 1, correct? So அப்ப எது அதிகமா தேவைப்படுது அப்படினா oxygen அதிகமா தேவைப்படுது. ஏனா 1 mole க்கு இது 1 கூட தேவைப்படல, 1 ஓட கம்மியா தேவைப்படுது. Or looking at other way around, இது 1 mole நான் யூஸ் பண்றேன் அப்படினா இது 1 இல்ல 1 ஓட அதிகமா தேவைப்படுது. Meaning I always want more of oxygen. So now what we can do is ரெண்டுமே 1 mole கொடுத்திருக்காங்க. அப்ப இது 1 mole கொடுத்தா இது எவ்வளவு தேவைப்படும்? 1 ஓட கம்மியா தேவைப்படும். இருக்கா? இருக்கு. So this is my limiting reagent. Okay, let's look into it this way. எனக்கு இது 1 mole கொடுத்தா இது 1 mole அதிகமா தேவைப்படுது. இருக்கா? இல்ல 1 mole தான் கொடுத்திருக்காங்க. So I don't have a lot of this. So this is my limiting reagent. This is my excess reagent. Okay, this is how you want to do. Now next step what we can do is limiting reagent தெரிஞ்சதுக்கு அப்புறம் I can predict what is the amount of product I can form. 5 mole gives you 4 mole or 6 mole. அதை கண்டுபிடிக்கிறதுக்கு பதிலா 1 will give you 4/5 mole. எனக்கு எவ்வளவு moles கொடுத்திருக்காங்க? 1 mole கொடுத்திருக்காங்க. So 1 mole will give you 4/5 mole. So I will end up forming 4/5 moles of NO or 6/5 moles of water liquid. Now the beauty of this is I am doing everything in moles. Moles is equatable. 4:5 நம்ம சொல்லலாம். ஆனா 4 grams 5 grams ஓட ரியாக்ட் ஆகும் நீங்க சொல்ல முடியாது. 4 liters 5 liters ஓட ரியாக்ட் ஆகும் நீங்க சொல்ல முடியாது. Although here you can say because it is gases, it's a different type of volume. Generally moles is the one that connects. So என்னால இத பண்ண முடியும். இப்போ என்னலாம் क्वेश्चन கேட்கலாம்னா other than this I can ask you which is the limiting reagent. How much of ammonia is left over? How much of NO is formed? How much of H2O is formed? Now if they ask you in moles, simple, we already know. What if they ask you in grams or volume? Let's look into it. Now, for the given problem, what is the correct option? 1 mole of H2O is produced. Okay. Now I figured out my limiting reagent, and what is the amount of H2O produced? 6/5. 6/5 is not 1. Greater than 1, less than 1 doesn't matter. 1 mole is not produced. Coincidentally, it is greater than 1. So this is a wrong option. Second one, 1 mole of NO is produced. No, 4/5 moles of NO is produced. All oxygen is consumed. Yes, because it's a limiting reagent. All ammonia is consumed. No. So option C, or I like to call Charlie, alpha, beta, Charlie, delta. Charlie is the correct option. Now let's look into what all we can do. We can actually end up calculating few other things. Let's calculate those things. Now let's look into it. What is the moles used? 1. What is the moles used? 4/5. Moles left. I start with 1, I use up 4/5, I am left with 1/5 moles or 0.2 moles. How much is left over? எல்லாமே யூஸ் ஆயிட போகுது. So 0 moles is left over. How much of this is left over? NO 4/5 moles. So I can say it is 4/5 or 0.8 moles. Now if you want to quickly do how to get 0.8, extremely simple, make it 40. 40/5 is 8, move one decimal place, 0.8. Now this type of math you have to do faster, it comes over a period of time, no need to practice separately right now. So now this is 6/5. Okay. Now 6/5 what you can do, make it as 60/5. 60/5 is 12. Upper 6/5 now 1.2 moles. Now I can do moles left, grams, okay, left. Grams எவ்வளவு left இருக்கும்? We know from previous lecture moles equals mass over molar mass. So now I have my mass required, that equals moles times molar mass, which is mW. So now I am going to have here 0.2 times ammonia. So these are certain things that you want to remember right away. Ammonia 17. So this is 0. So I have here 0.8. 0.8 times 31. Oxygen plus nitrogen. Sorry, not 31. 30. Okay, 14 plus 16. Now water is 1.2 times 18. Now do I have to do this math? Not really. நீங்கள் இந்த பண்ணணுன்ற அவசியம் இல்லை. You can look into the options. என்ன கேட்டிருக்காங்கன்னு பார்க்கலாம். Which is left over. If you want to do the math over a period of time, you will know 17 times 2 is 34. So this is 3.4, 0, 2.4, 18 and 12. What you can do is there are multiple ways to do. You can do exactly 18 times 12 or 18 times 1 பாருங்க. What do you get? 18. So 18 ஓட கொஞ்சம் அதிகமாக இருக்கும். You can do that. Or you can exactly calculate it if you want. If you exactly calculate it, you will get 2.16. This is how we are going to do limiting reagent problem. No, so I have figured out what is my limiting reagent based on only one thing. எனக்கு ஃபர்ஸ்ட் எல்லாமே மோல்ஸ்ல வேணும். இந்த क्वेश्चनல மோல்ஸ்ல கொடுத்திருக்காங்க. If they give you in grams, you have to convert it into moles. ஏனா இந்த ரேஷியோ வந்து மோல் ரேஷியோ, கிராம் ரேஷியோ கிடையாது. So anytime you are given a balanced equation, calculate the mole ratio, calculate the moles of each of them given if mass is given, calculate the moles, and then you can calculate which is the limiting reagent based on that. We will do few more problems to calculate all those. Now one more thing I want to say here is, நம்ம grams calculate பண்ணோம். We can also calculate what is the volume at STP. Volume at STP. So STP நமக்கு என்ன தெரியும்? 1 mole is equal to 22.4 liters. Okay? 0.2 moles அப்ப எவ்வளவு இருக்கும்? 0.2 times 22.4. This is 0. This is 0.8 times 22.4. This I cannot calculate. The reason is this is for a gas that's given as liquid. If suppose same balanced equation adhi avanga gas nu sollita, all you will do is ivlo moles form aayirukku 1.2. 1 mole வந்து 22.4, 1.2 வந்து 1.2 times 22.4. You can calculate accordingly. So this is how I can calculate from a given one grams or molar volume. Alright. We look into the same limiting reagent concept with another previous year question. It came in 2003. என்ன சொல்லியிருந்தாங்கன்னா Haber's processல 30 liters of reagents ரெண்டுமே கொடுத்திருக்காங்க. It's a gas. How much of everything will be left over if the reaction goes 50% completion? 50% completion, it comes under equilibrium because it's an equilibrium process. 50% at the equilibrium. Let's look into 100% ஆயிருந்தா என்ன இருக்குன்னு முதல்ல பார்க்கலாம். Now what you want to do? There is a shortcut here. Gases பொறுத்த வரைக்கும். Let's say for example you take a balloon. Balloon வந்து 1 mole gas உள்ள இருக்கு அந்த balloonல. So now if I take a balloon, so there is 1 mole 22.4 liters. What if you heat it more? It will become 24.8, 20 degrees for more. At some temperature if you cool it, and the balloon cool ஆனா என்ன ஆகும்? ஃப்ரீசர்ல நீங்க balloon வச்சா தெரியும் shrink ஆகும். So it becomes small. Let's say this is, it becomes 1 liter. Alright. So அப்ப ஏதோ ஒரு கண்டிஷன்ல ஒரு மோல் வந்து 1 liter தான் ஆக்குபை பண்ணோம். Let's assume that condition. Why? Because they don't give you condition. Meaning இதுக்கு என்ன கண்டிஷனோ அதே தான் இதுக்கும் இதுக்கும். So it's easier. So if 1 mole is 1 liter, what we can do here, moles is how many moles? 30 moles. 30 moles. It's much easier right now. 30 moles, 30 moles. 1 mole needs 3 moles. 30 mole needs 90 moles. I don't have. So this is my limiting reagent. Or other way around. 3 mole needs 1 mole. 3 mole க்கு 1 mole தான் தேவைன்னா 30 க்கு எவ்வளவு தேவை? 10 தான் தேவை. I have more than that. So this is my excess reagent. This is my limiting reagent. So used up. 100% use ஆகுதுன்னா all 30 moles will be used up. 3 uses 1. அப்போ 30 will use up 10 moles. What will be left? I will have 20 moles of this left and 0 of this left. You can look into this. 3 moles gives you 2 moles. Correct? 3 moles gives you 2 moles. Appa 30 moles will give you 20 moles. We are still in the same condition. Reactant ku enna condition vechumo adhe dhaan product ikum. So 1 mole endradhu 1 liter. So what is left is 20 liters, 0 liters, 20 liters. That will be your answer if it is 100% completed. Right? Now let's look into 50% completed. If 100% completed was too fast for you, rewind the video, watch it again before you proceed any further. Okay, 50% completed. அப்பயும் நீங்கள் limiting reagent க்கு தான் வரணும். Limiting reagent is hydrogen. 30 liters கொடுத்துருக்காங்க, we assumed it as 30 moles. 50% தான் கம்ப்ளீட் ஆகுது அப்படின்னா எவ்வளோ யூஸ் ஆகும்? What is given is 30 moles. Used up will be 15 moles. Why 15 moles? 50% தான் யூஸ் ஆகுது. 100% 30 moles யூஸ் ஆகிட்டு இருக்கும். If you want, you can differentiate it by saying minus. ஏன்னா யூஸ் ஆகுதுன்னு சொல்லலாம். 3 moles uses 1 mole. Correct? 3 uses 1. 30 used 10. அப்போ 15 எவ்வளோ யூஸ் ஆகும்? 5 moles is used up. Leftover is how much? 25 moles nitrogen is left over. 15 moles hydrogen is left over. How much of ammonia is formed? 3 மோலுக்கு 2 மோல் ஃபார்ம் ஆகுது. கரெக்ட்? 3 மோல்ஸ்க்கு 2 மோல்ஸ் ஃபார்ம் ஆகுது. 30 மோல்ஸ்க்கு 20 மோல்ஸ் ஃபார்ம் ஆகுது. அப்போ 15 மோல்ஸ்க்கு எவ்வளோ ஃபார்ம் ஆகும்? வெரி சிம்பிள். 30க்கு 20, 15க்கு 10. Now we are going to use the same. 1 mole is 1 liter. We are in the same condition. So the final composition is 25 liters of nitrogen, 15 liters of hydrogen left over, and 10 liters of ammonia formed. So total volume of mixture. This question I கேட்கலாம். When the reaction is done, what is the total volume of mixture? 25 plus 15 plus 10. Okay. 50 mils. Starting is 60 mils, ending is 15 mils, because the total number of moles decreases as you go to the other side. Because it decreases, you end up with a different quantity. Okay, this is how you do a limiting reagent problem. The same thing will come over and over again, but the numbers are extremely simple. One big mistake some people will make is in the 30 liters exact moles are மாத்துவாங்க STP ல. No need to. இங்கே நான் 22.4 டிவைட் பண்ணனா எனக்கு எக்ஸாக்ட் மோல்ஸ் கிடைக்கும். 30 divided by 22.4. பட் ஐ cannot do the math. It's very very tough. பட் அப்படி எடுத்துக்கிறதுக்கு பதிலாக இந்த அசம்ஷன் மட்டும் பண்ணிங்கன்னா we will see more of this assumption in gas loss. Gas loss பண்ணும்போது we are going to see this a lot more. Okay.